One of the great advantages of being up here, and probably the only one as far as I can see, is I can take my mask off. Huge sense of relief as soon as I took that mask off. I'm sure you share the feeling. I've given my talk the title, Why Haven't We Made More Progress on Climate? But that's not actually a terribly good title. A better title would be a collection of thoughts provoked by what's been happening in Glasgow over the last week or so. And one of the issues I'll be talking about is the one which is in the title there, but it's one of several. In the process of the talk, I'll actually be picking up, slightly surprisingly actually, picking up some points that Eric Maskin was talking about in his extremely lucid talk about voting yesterday. And I'll also be picking up some points that Richard Sennett was talking about in the dinner talk yesterday. And I'll actually also be picking up a point, and this surprises me even more, that Greta Thunberg, according to this morning's Guardian, was making in Glasgow yesterday as well. So let me start off by taking the title literally and talking about why we haven't made more progress on climate change. And there's a bunch of very obvious answers to that. I want to talk about a rather less obvious one. And the obvious ones are these ones here. The power of the fossil fuel lobby. You know, we've got a Democratic Congress, we've got a Democratic president, but we've got a senator for West Virginia who's paid a lot of money by the fossil fuel lobby and is still capable of blocking everything. You know, the fossil fuel lobby even today has more power apparently than the US president does. And that's been the case for decades. I mean, the extent to which the fossil fuel lobby has managed to misinform the public and to effect legislation or block legislation has been very well documented by a number of writers. So that's not something I want to talk about. What I want to talk about is the fact that actually the economics profession, which is very well represented in this room here, has actually not pushed as hard as it might have done, to put it mildly, for action on the climate front. And a very good example of this is given by the reception that the Stern Review of the Economics of Climate Change got when it was published in 2006. For those of you not in the field, Nick Stern is a very distinguished British economist. And back in, I think it was 2006, he wrote a thing called the Stern Review of the Economics of Climate Change. At that point, he was the chief economic advisor to then Prime Minister Tony Blair. And the Stern Review made a strong economic case for rapid and prompt action to mitigate carbon emissions and for rapid action on climate change. Now, the review's reception, particularly by the sort of economics establishment in this country, was extremely hostile. That's probably putting it mildly, actually. Bill Nordhaus, who's a very distinguished guy at Yale, wrote that the review's unambiguous conclusions about the need for extreme immediate action will not survive the substitution of assumptions that are consistent with today's marketplace real interest rates and savings rates, which is basically a way of saying that Stern was using the wrong discount rate. And I'll come back to that and spend a bit of time on that later on. He goes on to say, one of the major findings in the economics of climate change has been that efficient or optimal economic policies to slow climate change involve modest rates of emission reductions in the near term, which obviously is a very controversial point in the present context. I mean, very few people would agree with that right at the moment. And many other prominent economists agreed with Nordhaus, and Marty Weitzman, that was then at Harvard, wrote in the same issue of the Journal of Economic Literature, criticizing the Stern Review on somewhat different grounds, but still criticizing it. So why was there this big disagreement about the need to take prompt action in mitigating climate change? There are two kind of conceptual obstacles here. One was the difficulty in modeling the damages resulting from climate change. And the second was disagreements about the discount rate. And that's probably the larger of the two. Let me just emphasize the importance of the discount rate. We discount present future benefits relative to the present. And the rate at which we discount those is a very important variable when you're looking at benefits which and costs which are stretched out over very long periods of time. If you're looking 5 or 10 years ahead, the choice of the discount rate is not crucial. If you're looking 100, 150, 200 years ahead, which is typically what you are doing in climate change, the choice of a discount rate is absolutely critical. So in the bottom bullet point there, I've just given you some illustrations. The present value of $100 1 century ahead is $0.76, 76 cents at a 5% discount rate. But if you shift the decimal point on the discount rate by 1 and make it 0.5% discount rate, then the other value is $60. So if you shift the decimal place 1 on the discount rate, you shift the decimal place 2 on the resulting present value. So the present value is enormously sensitive to the value of the discount rate you choose. And it happened that Stern, in his review, picked a discount rate which was closer to 5%, to 0.5%, whereas Nordhaus characteristically works with a discount rate which is closer to 5%. And you can see that alone would result in huge differences in the emphasis they place on events in the future. Now, I come back. I'm going to talk first about modeling climate damages, but I'll come back to this point about the discount rate. And let me just make it very clear at the beginning that I'm not claiming that either of these people are right or wrong. I'm not saying that Stern is right and Nordhaus is wrong or vice versa. I'm actually going to argue that they both have quite legitimate positions and that we need to find a way of making decisions in the light of that fact. And I'll talk about how we can do that. So just let me make some brief remarks about climate damages. As I said, there really isn't a lot of general agreement on the costs to the economy of extensive climate change. There's a set of things called integrated assessment models, which are computerized models that essentially integrate a model of the economy, a very simple sort of growth model of the economy, with a very basic model of the climate system. And there's feedback between the two, so the active action of the economy generates climate change, which in turn affects the economy again. And Bill Nordhaus, one of his claims to fame, he has many claims to fame incidentally, is that he was the first person to develop these integrated assessment models effectively. Now these integrated assessment models, a critical part of these models is what's called the damage function. And that's the functional form which represents how a change in temperature affects the economy and society in general. And one of the weakest links in all of these models is these damage functions. We really don't understand very well how temperature affects the economy. And as a result, the damage functions are essentially based on what I personally would call casual empiricism. I mean, the authors of the models wouldn't want to use that phrase, obviously, but I think that's not a totally unfair comment. Sometimes there's an emerging econometric literature, a statistical literature on the effect of climate change on the economy, looking at what effect climate change to date has had on the economy. But because the climate has only changed by a relatively small amount, global mean surface temperature has gone up by about 1 degree in the last 50 years. So that's not a very big change. So it doesn't give you an awful lot of data points. But we're interested in knowing what would happen if the global mean surface temperature went up by 4 degrees, 5 degrees. And that involves extrapolating a very, very long way out of sample. So the margin of error on that is absolutely huge. So it's not particularly easy to get good estimates of the damages from climate change. Bob Pindyck, who's a prominent economist at MIT, has made some fairly trenchant comments in the Journal of Economic Literature about these integrated assessment models. And I've got a couple of them here. He says, integrated assessment models have crucial flaws that make them close to useless as tools for policy analysis. And they tell us nothing about the most important driver, the possibility of a catastrophic climate outcome. Now, a lot of economists actually agree with Pindyck. I mean, these models are not, I think to say that they're useless as tools for policy analysis is probably fair. They're not useless, though. I mean, you can carry out conceptual experiments with these models, and they're interesting in that context. You can get kind of general qualitative impacts from them, but it's hard to get quantitative impacts and believe in the numbers precisely. So let me flip from that to talking about discounting, which is the main topic I want to talk about. There's two traditional approaches to picking a discount rate. And as I said earlier, the choice of a discount rate is critically important here. One is to consult the market, take a discount rate from the market. And that's what Nordhaus was saying you ought to do in that quote I had from him up in a couple of slides back. And this is the approach which is most widely used by governments. So the US government consciously picks a discount rate. OMB, the Office of Management and Budget, picks a discount rate which is in some way related to market discount rates. The alternative approach is to imagine what we might call a benign planner, whose job is to make intertemporal allocation decisions, considering the interests of all generations, present and future. So the benign planner is specifically briefed to take into account not only our interests today, but those of all future generations. And then ask, what would such a benign planner choose, given a reasonable ethical framework for making such choices? And that's probably the default in academia. This is the framework which was set up by the first ever paper on growth theory, a paper by a guy called Frank Ramsey, who wrote in Cambridge in the 1920s. He wrote a very famous paper called A Mathematical Theory of Saving in 1928. This is the framework that Ramsey set up there, and it's been universally used ever since then. So let me talk briefly about both of these approaches. The market rate first. So markets are supposed to synthesize individual preferences and tell us something about what the common factors in individual preferences. That's supposed to be reflected in market prices. Now, there are a lot of assumptions have to hold for that to be the case. One critical assumption here is that everybody whose preferences are relevant has to be participating in the market. If we're talking about things happening in 2050, 2060, 2100, that's clearly not the case. A lot of the key players, future generations, are just not represented in the market. So it's, I think, a mistake to think that a market existing today can fairly represent the interests of future generations there. Then there's a huge range of market imperfections that prevent markets from revealing the, quote, right, unquote, rate of time preference. Now, there is an argument that if, and as I said, under very stringent conditions, markets can give you useful information about how to value the future relative to the present, based on a kind of a synthesis of individuals' choices in this respect. But those conditions include, for example, that you have a complete set of what we call a complete set of futures and contingent markets. It means, for example, that you can trade today goods for delivery in all future periods, including future periods towards the end of the century. Now, we do have futures markets, and you can trade today goods for delivery 5 or 10 years ahead, but you certainly can't trade for delivery goods 50 or 60 years ahead. So that's what we call an incompleteness in the existing market structure. The other big omission here is the existence of externalities, external effects. You know, when a transaction between, say, me and Joe there has an impact on third parties. That's what we call an external effect, and Nick Stern described, I think quite rightly, climate change as the greatest external effect in human history. So when you have incomplete markets, when you have externalities, then the market no longer actually conveys an accurate signal about the rate of time preference. So this is an equation. You don't need to know the details of this equation here. This is what's called the Ramsey rule, going back to that guy Ramsey I spoke about. And it tells you that the rate at which you might want to discount the future is equal to the return on capital, which is an observable parameter in capital markets. So under the whole range of very strict conditions I've just mentioned, there is a connection between observable data in capital markets and the rate at which you might wish to discount future costs and benefits. I say might, because there's a number of arguments for and against that. If, however, you introduce climate change and you modify the model so as to take account of the kinds of factors that integrated assessment models do, which is that temperature is affected by economic activity and damage, the result is a damage to the economy, which is roughly what that first equation there is saying, then you get, instead of that equation we had just now, you get this one. And the terms in red are terms which are not in the previous equation. It's the bottom line here is that I'm not going to try and explain what this equation says, but the bottom line is it's a very different equation. And you can no longer read off the appropriate discount rate from market observable parameters. In order to calculate the appropriate discount rate from market observable parameters, you have to know a lot of other things, which we typically don't know, about exactly how the climate system responds and about exactly how the climate system affects the economic system. So markets in general will give an inaccurate signal in that situation. And there's a bunch of other reasons, which I haven't got time to go into, why one would doubt the value of market signals anyway. Let me talk instead about the benign planner approach. So the benign planner approach is typically a very utilitarian approach. You maximize the present value of the sum of utilities over some planning horizon. This requires that we pick certain key parameters. One key parameter is the discount rate, which is always represented by delta. The other one is something called the elasticity, represented by eta there, which is essentially a measure of your preference for equality over inequality. And both of these are very controversial parameters. There's no general agreement on what these are. There is, for example, a strong constituency for setting delta equal to 0, which means you treat future generations exactly like present generations. And in fact, Ramsey in his original paper made this rather unambiguous comment here. He said, discounting of future utilities is ethically indefensible and arises purely from a weakness of the imagination. What an obiter dicta. His brother went on to become head of the Church of England. And you can see that coming out in a sermon, can't you? Harrod, who was a contemporary of Frank Ramsey, said, discounting is a polite expression for rapacity and the conquest of reason by passion. Pigou, who was essentially the founder of environmental economics, said rather more moderately, it implies that our telescopic faculty is defective. And a contemporary, almost contemporary of ours, Bob Solow, said that in solemn conclave assembled, so to speak, we ought to act as if the social rate of time preference were zero. So there's a lot of very prominent people saying we ought to pick a zero discount rate. We ought to treat future generations like we treat the present generation. But actually, if you try and do that, it turns out that implies an enormously high savings rate, very unreasonably high savings rate. And one of my great heroes, Ken Arrow, went on to say, what I think is the definitive statement on this. He said, I therefore conclude that the strong ethical requirement that all generations be treated alike, itself reasonable, contradicts a very strong intuition that it is not morally acceptable to demand excessively high savings rates of any one generation or even every generation. So there's a sort of, Ken is saying there's a kind of a contradiction, an inherent contradiction here. And that point has been proved formally, actually, by a guy called Peter Diamond at MIT and by some other people. Let me skip that. And the key point, let me just focus on this red line here. Ramsey's paper is now almost 100 years old. We've been debating the correct values for delta and eta for 100 years. Well, actually, 92 years. And unfortunately, we still haven't agreed. And so the prospects of agreeing in the near future are probably rather small. So we need to find another way of dealing with this. And that's what I'm going to suggest. And that's why I'm going to pick up a point that Eric was making yesterday. And just to get us into, there are very important disagreements here. Let me just give you this diagram. This is from a survey of economists who've written on climate change, which asked them what they think are the correct values for delta and for eta. Each point is an economist or a group of economists, and the time preference is on the horizontal axis. The value for eta, the elasticity, is on the vertical axis. And you can see there are people who have, does this thing have a pointer? No. There are people who think, for example, that the right rate of discount is 8%, although a lot of people think the right rate of discount is 0. There are people who think that the right value of the elasticity is 6, and there are also people who think the right value for that is 0. If you take the difference between the guy who's at the origin, there's one guy there at the origin who thinks that both numbers are 0. There's another guy who thinks that the right value for the discount rate is 6%, and the right value for the utility is, if the elasticity is 4%, is 4. If you take the difference between how they value $1 100 years from now, the answer is the ratio is 500,000 to 1. Really amazing difference, absolutely amazing difference. So there really is a lot of disagreement, unfortunately, within the profession about this. And what I've argued in a paper with co-author Anthony Milner is that we simply have to learn to live with these differences. That we have to recognize that people's choices of delta and eta are essentially parts of their value systems. There's no right or wrong answers on these, because these are ethical judgments, and there's no more a right or wrong answer on these than there's a right or wrong answer to the question, what's the right distribution of income? People can legitimately differ in their opinions on this. So we need to find a way of moving from differing values to an acceptable social choice, which is precisely the framework that Ken Arrow wrote about in 1953 in his book, Social Choice and Individual Values. There are several ways of doing this, and in the paper that I'm basing this on, we discussed this. I'm flipping through these rather quickly because I think I'm running out rather low on time. But essentially, one way of tackling this is to have people vote over this issue, which is what I'm picking up from Eric's comments yesterday, obviously. There's a variety of approaches to that, as Eric actually outlined yesterday, and we investigate a number of different alternatives here. In the process, incidentally, we pick up some ideas from a paper that was written by two people called Phelps and Pollack in 1968, Review of Economic Studies, Game Equilibrium Growth, a very profound paper and a very early paper in this area. So basically the earliest paper on Markov perfect equilibria. Very nice paper, incidentally, in it, and we use some of the results in that. Anyway, so I haven't really got time to go into detail here, but we can actually show that under certain conditions, which are, I think, reasonable conditions, a great majority of people will prefer the outcome that comes from voting to a bunch of other alternative outcomes. So there's actually a lot to be said for treating this as essentially a political process rather than an economic process. The particular condition on which this is true is that inequality it's an inequality concerning the distribution of discount rates amongst the population. The left-hand side is the harmonic mean, the right-hand side is just a straight mean, arithmetic mean, and the median has to be between them. that's true for most of the distributions we've seen, actually, of discount rates. So maybe skip this and go to one more point. This is the point where I'm going to connect with what Greta Thunberg, according to today's Guardian, was talking about yesterday, which is the issue of corporate approaches to climate change. As I'm sure all very well aware, many corporations in the last month or so have made pledges to be, quote, net zero, unquote, by 2050. And in many cases, they're planning to use offsets to get to zero. And there's two questions I want to tackle. Maybe I just have time for the first one, actually, which is the use of offsets. But the two questions this raises are, is the use of offsets legitimate here? And secondly, how do we measure emissions? How do we measure corporate emissions? There are three measures of corporate emissions: Scope 1, Scope 2, and Scope 3. You're probably mostly familiar with those. I'll define them in a minute if you're not. So what's an offset? An offset occurs when you persuade another entity to reduce its emissions, and you pay them for the right to call that reduction yours. So if I persuade you to reduce your emissions, and I pay you for that, I can claim the emission reduction as mine. And that's what's called an offset. And if you look at the sort of statements that most corporations have made on their intentions to go net zero by 2050, they all involve extensive use of offsets. Now, the basic point I want to make, 2 points I want to make, actually. One is that the world cannot get to zero via offsets. A fairly obvious piece of arithmetic. Suppose that E are the emissions of a country today, E sub I are the emissions of country I today, or country I, company I. R sub I is the reduction it brings about in its emissions by, say, 2050. And O is the offsets it purchases, so as to be net zero. Then obviously these have to satisfy the equation there, E minus R minus O equals zero. Emissions of entity I minus the reduction in emissions by entity I minus the offsets has to equal zero. That's what it means to be net zero using offsets. Now, if we add that up over all entities, let's say over all corporations, we've got that the sum of emissions minus the sum of reductions is equal to the sum of offsets, obviously. And the sum of offsets is not zero. Therefore, there's still a net positive emissions. That's intuitively very obvious. But if every company can claim to be net zero by buying offsets, but the world as a whole is nowhere near zero. And that's the fundamental flaw with offsets. Okay? Now, there's another point about offsets, however, slightly around the contradiction. This is a very quick example. Country A can reduce emissions for $70 a tonne. Marginal cost of reduction is $70 a tonne, but it's only willing to pay $60 a tonne. So it won't on its own reduce. Country B can reduce emissions for $50 a tonne. So its marginal abatement cost is just lower, $50 a tonne. Might be a developing country. It's often cheaper to abate in developing countries. But it's only willing to pay $40 a tonne. So neither country on its own will cut back emissions. However, country A can pay country B to reduce emissions profitably. So the introduction of an offset market, an international offset market, actually creates a reduction in emissions which would not otherwise have occurred. Okay, so the offset market has facilitated an emission reduction. Okay, so the bottom right line here is there is a role for offsets. Offsets can generate reductions in emissions which would not otherwise have occurred. But in the end game, all offsets have to be zero. If we're going to be net zero in 2050, there must not be any offsets left there. They all have to be phased out by then. Okay, just one more line. So now, how does this connect with Greta Thunberg? Greta Thunberg was apparently going on about the evilness of offsets at the meeting yesterday, so I just mentioned the connection there. Okay, final category issue, categories of emissions. Scope 1 is direct emissions from operations. So, for example, Columbia University burns natural gas in order to heat its buildings. The CO2 emissions coming from that are Scope 1 emissions. Scope 2 emissions, emissions from power purchased. So Columbia University buys electric power from generators. In the process of generating that power, they're producing CO2 emissions. That counts as our Scope 2 emissions. Scope 3 emissions, all other emissions associated with the supply chain and with the use of the product. Now, obviously, as soon as you think about this for 5 minutes, there's a massive amount of double counting there, right? I mean, if you just cannot add these things up and get a reasonable number. Because, Columbia University's Scope 2 emissions, which are the emissions associated with the electricity that we buy, are somebody else's Scope 1 emissions. Exxon, for example, sells gasoline, let's say, to American Airlines. When that gasoline is burnt, it produces CO2 emissions. That's Exxon's Scope 3 emissions, but it's also American Airlines Scope 1 emissions. And if American Airlines is running an aircraft made by Boeing, it's Boeing's Scope 3 emissions. I've actually found some things in this data which are counted, not just double counted, they're counted 5 times when you add all these things up. So this process is actually not very informative. If you think about it carefully, if every company gets its Scope 1 emissions down to 0, there are no emissions left. So the instructions we should give to companies, and this is what picks up from what Richard was talking about at dinner last night, the instructions we should give to companies are reduce your Scope 1 emissions to 0, forget about the rest of them, and don't use offsets. You can use offsets to get there, but in the end game, the offsets must be 0. I've way overstayed my welcome, I'm afraid, so I'm sorry about that, but I hope it's been entertaining. Thank you.
We actually have time for about 1 or 2 questions.
Oh, that's surprising. Good. Thank you.
I'm just curious about the debate, the 100-year debate. So is that an American debate, or is it involving economists from other countries?
It's a kind of transatlantic debate, actually, isn't it, Joe? I mean, I think on the whole, Joe knows more about this than I do, but on the whole, the British economists or European economists tend to be in favour of low discount rates, and the American economists tend to be more market-based and arguing in favour of a market discount rate. But there are exceptions, and I'm this side of the Atlantic, and I'm in favour of a low discount rate, and I'm sure Joe is too. I think probably Eric is as well. Yes.
Economists in East Asia that have been surveyed also? Any other, like, broader beyond the West?
That's an interesting question. I know a number of obviously Asian economists, but I'm not aware of what their position is on this issue. Anybody in the audience know that? Plenty of prominent economists here, but no. Yeah, we might. Yeah, I mean that survey that I cited earlier on by a guy called Moritz Drupp. That survey is supposedly actually most economists who've written on the issue of climate change. That would naturally include both some Japanese and some Korean economists. They're mainly people who are operating in this country.
Jeff, you're absolutely right about the dispute over the discount rate, but I wonder whether to some extent it might not be a false debate. That is, there are really 2 things going on. The way individuals regard the future and discount the future, and the way that we as a society regard future generations. And there's no particular reason why those 2 discount rates have to be the same.
Yes, well, that's absolutely right. I mean, and that's really the big difference between the market approach and the benign planner approach. I mean, the market essentially takes individual attitudes towards the future, your attitude and my attitude and so on, synthesizes those, whereas the benign planner, in principle, is taking a kind of a more intergenerational perspective, based less on individuals' assessment of what the future is worth to them. Yeah, that's right. That's a good way of putting it, actually. Thank you.
Yeah, let me say, one can put it in a slightly different way, which is that if you believe that there was an actual planner, the government redistributed income optimally across generations, then there might be an argument that there, apart from the externalities that you identified, that there be some relationship between social discount factors and the market interest rate. But if you don't, if you have an overlapping generations model, if you have people with finite lives, or there's not, then you wind up in the kind of world that Phelps and Pollock are in, and there is no reason that you would expect that there be any relationship between the market rate of interest and our ethical valuations. And just to, I was in charge of the committee that sets the interest rates in the Clinton administration, and we had a lot of fight. The view that I expressed is that it should be a very low number, and lower than the market rate of interest.
Absolutely.
And that view, particularly for long-term climate change purposes. And one way of thinking about it is that the market rate of interest that in terms of what is the consumer rate of interest, not the producer, which is the safe rate of interest, is already 0.5% or lower. It's been negative recently. The market rate of interest that we see in the return on capital embeds risk and market imperfections.
Right.
And that if you incorporate any reasonable perspective on the risk and the states of nature where climate change is worse than we think, reflecting the uncertainty, then you would think of climate mitigation as an insurance policy.
Precisely.
And you would want to use an interest rate lower than the safe rate of interest. So I guess my view on this is that if you look at it from these perspectives, it's not just a question of opinion about what the delta is. It's a question of bad economic analysis, and that the integrated assessment models just have gotten, left out things that are almost obviously true, that we don't optimally redistribute, we don't optimally manage risk, and that there is this negative correlation.
Yeah, I agree with that. And I think you've made an important point there, actually, Joe, which I didn't have time to make, which is that people talk about the interest rate, but actually there's a multitude of interest rates depending on the time period that we're dealing with and the risk parameters that we're dealing with. And most governments actually use a single interest rate, which is independent of the maturity of the project and independent of the risk classification of the project, and that's clearly wrong. So if you're going to rely on the market, you need to differentiate by maturity and by risk category, which, for example, OMB doesn't. Yeah.
We're running out of time, but okay, we can do a couple more then, says Lizzie. David was here waiting.
Just a quick question. I was curious to know if you thought that there was particular relevance for tracking Scope 3 emissions in the banking sector, which is somewhat of a new thing that they're tracking as opposed to
Well, I think
Scope 1.
There's a lot of attention is focused on the banking sector, and I think that the issue there is not so much the magnitude of their Scope 3 emissions, because those are always somebody else's Scope 1 emissions. The issue is, can they in fact be used as a vehicle for putting pressure on people to reduce emissions? I mean, because there's the follow the money argument. Constructing coal-fired power stations has to be financed. They're very capital intensive, and it's usually 4 or 5 years before they produce any income. Therefore, they need building finance, loan finance. And if you can persuade banks that's not a right thing to do, then they won't be able to build coal-fired power stations. So I think that's why activists are focusing on banks, because they play a strategic role in funding some of these carbon-intensive projects. And I think it's better to think of it in that category than it is to think of it as a Scope 3 emission issue. Bruce.
Jeff, how does population growth or population shrinkage fit into this?
That's an interesting question. It actually just usually doesn't feature in these models. They take an exogenous population growth. Obviously, in practice, the fact that by 2050 we expect the world's population to go up by, what, 1.5 billion or something horrible like that, makes the problem much worse. And it means that the future, it means that typically we'd expect people in the future to be somewhat less well off than today, simply because of the pressure on resources and other things being equal. But I don't think... it's a lot more. Yeah, right. So I mean, if you weight costs not only by their futurity but by the number of people experiencing them, it increases the salience a lot. Yeah, that's an interesting question. Most of these IAMs don't have a very specific treatment of population. It's just sort of exogenous. Very few of them build in any explicit modeling of how population is likely to grow over time.
Except in one respect, which is that there's a probability that the world has extinction for other reasons.
Yes. Yes.
And so that is used as the argument for a delta, that if there's nobody, we don't have to worry about climate change.
Yeah, that's the argument in the Stern Review. That's Nick Stern's argument. That's right. Yes. Yes.
All right, so I think with that, we will turn things over to Joe.
Okay,
for
right. Thank you very much.
Thank you.